in songbirds, like how intelligent are these animals? Just I know that's a broad question, but I'm kind of crazy, so I'm wondering, in your if I could get your opinion on like how much of this, like, are they having conversations? Kind of is what I'm trying to ask you.
I mean, so far what we can figure out about songbirds is that they're, at least the songs that they produce mainly during the breeding season, usually it's mostly the males, but also sometimes females, depending on the regions that sing. And they will usually sing to mark their territory and attract females. And from the evidence so far, it looks like the single units that they produce and the way they organize them mainly reflect their information about themselves. So their fitness, like how good of a male they are, how large is their territory, maybe testosterone levels, their age, who they learned the song from. So all kinds of things about themselves, but not necessarily about the context or like meaning per se, as we would call it in ourselves. So not about, they don't have a different, if you want, each unit or each song doesn't have a different function. The function is to attract the female. So it's quite different from other species, for example, meerkats or other species that will have a different call for each predator that comes around, where this is more close to what you would call a word in human language.
Okay. All right. So primarily in the... Oh, go ahead, John. What was that?
Oh, so you are correct. There, according to a study called "The Ravens Parallel Great Apes in Flexible Planning for Tool Use in Bartering," ravens are smarter than most human children. They say that it's like an analogous intelligence for tool use to great apes and humans.
Yeah, those birds are smart, and I know that cuttlefish as well are like very intelligent. I was at I don't know if you're familiar with Dr. Andrew Huberman. He studies the brain, and it's quite early here, so my brain's not firing on all its cylinders. But I had to get you on here because time difference be damned. But basically, one of the studies that he had, John, you'll have to pull this up too because I'm running on fumes here. But the cuttlefish were feeding these cuttlefish every day at the same doctors, and they were able to recognize these doctors, and they brought in a different professor, and they couldn't find the cuttlefish, right, because they're able to camouflage themselves. And when they finally found them, they're at the top of their tank. They'd completely, I don't know if they're translucent, and they had one eye on following all of them, this new person, and they were able to, like, because they didn't trust this person, they were able to recognize human faces, and that was kind of a crazy thing. And I definitely butchered that study, but John, you'll back me up whenever you find it. But
I did find it. It was a test designed for cognitive recognition for human children, and cuttlefish passed it.
Yeah. So there's some wild things going on in the animal kingdom, and that's why people such as yourself are incredibly important. Because I definitely think as human beings, we have this notion that we're probably the smartest thing on the planet, and I'm not 100% convinced. What makes us great is that we're able to manipulate our environment, and there's very few species that are able to do that. You have the beaver; they're able to kind of change and manipulate their environment, and I'm sure there's a few others, but that's the first thing that comes to mind. But when you start thinking about like what's in the ocean and whales, and the fact that they found languages in whales, especially orcas, and that was part of the problem with these parks that would have orcas in there, is they would start beating each other up or tearing each other apart when they figured out that they were speaking different languages, and there's certain pods that I'm sure have rivals. And so I'm wondering, all that aside, on the goats, you said you were able to find different dialects, with them, but like how much were they able to keep the ungulates that you've studied? Is it just goats that you've studied?
No, I've studied in terms of vocal expression of emotions, domestic horses, Shevetsky's horses, pigs, wild boars, sheep, and I think in cattle also.
And cattle. Ooh, what did you find out with pigs? Because pigs are pretty smart too.
Yeah, I mean, it was not on their cognition. So in terms of proper like cognition tests, I've only done that on goats, where we test what they can manipulate and how. So on pigs, it was on their vocal expression of emotions, and we basically carried out a pretty big study where we gathered lots of recordings in a collaboration between several teams, and we trained the machine learning algorithm to identify the emotion of the sounds, and the algorithm could classify 92% of the calls, so to tell us whether the call was produced in a emotionally positive or emotionally negative context.
Okay. So what? How you had a machine or an algorithm, right? A machine learning algorithm, yeah. Correct? And that was kind of how you studied it. And how would you get them to express, either negative or positive emotions in this study?
Yeah. So basically, we gathered all the recordings that we had in all the teams, which were from different contexts. For example, we had a team in Czech Republic working on piglets, so you had piglets in the farm being crushed by the mother. That happens sometimes, or missed nursing, or castration, which is part of the farm. And then also slaughterhouse recordings that we managed to get eventually, and more that we classified all as negative because there's context that the pigs should avoid and will threaten their life basically. And so we had other positive context, which was together playing in a familiar environment, or running freely in a corridor, or nursing, or after nursing from the piglets. So the kinds of things that would usually increase your chance of survival and were thus labeled as positive. And then we validated whether this was likely indeed positive or negative based on the behavior of the pigs. We also, for some of the context, had the heart rate to know how intense was the emotion. So we had their heart rate with a heart rate monitor. And then we produced a picture of the sounds and then trained an algorithm to differentiate, to recognize from the picture of the sounds which ones were negative or positive. And that's feasible across all the contexts we had. Okay.
So, all right, you went to these places and recorded these sounds and then plugged that back into the algorithm, essentially?
Yeah. So we were all teams that had been working on expression of emotions in pigs before. So we used existing recordings from previous studies, and we collected new ones that we were missing, like the slaughterhouse or the more positive context. And then we cut all these sounds out, and then we fed them to the algorithm and trained the algorithm to identify these sounds.
Oh, that's sweet. That's pretty sweet. First, I think I had that backwards for whatever reason. I was assuming that makes a lot more sense as opposed to how I would have maybe set it up. Because I may have played the sounds to the pigs, but how are you going to know? Or I don't know if you could have hooked something up like some sort of monitoring system. I don't know. It's not an EKG, and then like studied like the different reactions in the brain. And have there been studies like that done?
No, I don't know about their brain activity, but at least that's what we did also afterwards. So we played sounds of pigs to pigs and sounds of pigs to wild boars. So we did this study where we compared the cross species if they kind of perceive each other's emotions. So usually you would use a speaker and play back the sounds you recorded in a positive or negative context, and then see if you get some, if they differentiate between negative and positive sounds, and then also maybe if there is contagion of emotions. That's what we call contagion. So when you play negative sounds, they show behavior that indicates that they're in the negative emotions, and when you play positive sounds, they become, they experience positive emotions. And so we played pigs, wild boars, and human voice to the pigs and to the wild boars. And we did the same for domestic and Shevetsky's horses. And we see that they do react differently when you play them negative or positive sound, whatever species it is, except for the wild boars.
Ooh, so why not the white boars? Are you playing this? Are you playing white boars getting slaughtered, or do you think that they might not be able? Are you using? So you're using cross species, correct? In this study that we're talking about.
Yeah. Mm-hmm.
Do you have any idea why the white boars weren't able to respond to some of these sounds from other species? Do you have a hypothesis on this?
So first, the sounds that we played them were, so in this study, which differed from the previous pig study we were talking about, so we simply had contact calls. So everything we played was just simply grunts, like grunts, or for the horses, whinnies. So we played them grunts that were either recorded in a short-term isolation, for example, for the domestic pigs, or in when they were together foraging, which were positive grunts. So they differed only really slightly. Even for human ear, it's very hard to differentiate between the two. And so we saw that they somehow, so the pigs, they reacted stronger when we played them negative sounds of either pigs or human or wild boar. But for the wild boars, they only reacted differently to the sounds of the pigs, which was a bit strange. So it could be the context in which we played the sounds, or it could be something else. But it was quite interesting because they reacted showing more negative behaviors to the positive pig sounds and vice versa with the negative pig sounds. And it could be because they express emotions in a different way. So when we had compared in a previous study how pigs and wild boars express emotions, we saw that they have some parameters that change in the same way and others that are completely different. So it could be that for wild boar, the positive pig sound negative, actually, maybe because of the domestication process or something else.
Yeah, that's really interesting. That's actually kind of perplexing. It kind of throws a wrench in my thinking. I mean, because when you think about wild boars and pigs, it doesn't take long for a pig to kind of, I don't know, John, maybe look that up too. I don't know how long I think it's very, very short. When a domestic pig is able to break out, they completely transform into almost a different entity in a very short amount of time. Start growing hair, they start growing tusks. So I would think that those two, I don't know what causes that I don't know what causes that transition, which would be, honestly, I'm sure that's been studied. But
I was going to say, I've read that too, that they're also the shape of their nose goes from being flat and stubby to long and shaped like a trowel so they can dig. And if that same pig or previously domesticated pigs are re-domesticated, their body will change back to the kind of white fuzzy, normal pink
pinky
shape.
soft.
Yeah, exactly. Yeah.
Yeah. So that. Go ahead.
Sorry, they're very closely related. From what I remember, they don't have the same number of chromosomes exactly, but they are extremely closely related.